All right, so we have at long last a specific example. We're going to find all the extrema of this function, f of x equals 3x to the fourth minus 4x to the third. This is 3x to the fourth minus 4x to the third on the closed interval -1 to 2. This is a continuous function because polynomials are continuous everywhere. It is a continuous function because polynomials are continuous everywhere. That's a polynomial function. It's continuous everywhere. Therefore, it's continuous on this interval. So this is a polynomial which is continuous and is defined on a closed interval. So we know there must be an absolute maximum on this interval and an absolute minimum on the interval. So we have to find all the extrema. So here's the sort of to-do list. This is the process. This is the procedure list. Step 1, find all critical. Find all the critical values. Find all the critical values. And type 1, type 2. I don't know how long you're going to hang around the coursework, but as long as you're in any class I'm given, if you're in any class where I'm grading your work, if you find critical values, you need to write down TYPE space I colon. You need to write down type 1 and find the type 1 critical values. Then you need to write out the letters TYPE space Roman numeral 2. Every time, I mean every stinking time. Every time you write down type 1 and you find them. You write down type 2 and you find them. Every time, every time. All right? Here's the procedure. Type 1 critical values. Type 1 critical values. Where does type 1 critical occur? You write it down. Write it down. F prime is equal to 0. Every time. I don't care. If you don't want to have to write this, take somebody else for Calc 1. Every time you write it down. Type 2, that's where F prime does not exist. Every time you write it down. You don't want to write it down every time, take somebody else for Calc 1. Type 1, F prime is equal to 0. Type 2, F prime does not exist. Now, F prime is equal to 0, so you need to find the derivative. Find the derivative. So I got 12x to the third minus 12x to the second. All right. Now, type 1 critical value is we need to set the derivative equal to 0. Set the derivative equal to 0. Set the derivative equal to 0. You establish the condition to be met, and then you back solve to find what values cause that to occur. You establish the condition to be met. The condition to be met is f prime is equal to 0. Establish the condition to be met. The derivative must be set equal to 0. And then you back solve to find what causes that to occur. Anytime, I say again, anytime you set this derivative equal to 0, you need to write set equal. Again, you don't have to do that. Take somebody else for Calc 1, and they will make you do it maybe. You don't have to do it. Just don't do it, and then you're going to get some points taken off from your exam. But if you want to get full credit out of me, you're going to write, anytime you set a function to 0 for any reason, you write set that to 0. It's not an inherently true statement. This is a procedure you're following. Sam Lessig made me do it when I took Calc 1 way back in 1950, and I'm going to make you do it. I've done it to every Calc 1 student I've ever had. Anytime you set a function to 0, you write set equal to 0. And now you solve this like it's your glory days in basic algebra. I'm going to factor out, what are you going to factor out? I'm going to factor out 12x squared, leaving behind, what is that, x minus 1. And that's equal to 0. And then we get x equals 0 or x equals -1. Right? So there we go. Those are two critical values. One critical value is x equals 0. Another critical value is x equals -1. Those are the two type 1 critical values. All right? Found all the type 1s. Now we need to find all the type 2s. Find the type 2 critical value. Well, here's the thing. Not all functions have type 2 critical values. Not all functions have them. Some do, some don't. Not all functions have them. Polynomials. Polynomials never have type 2 critical values. Because the domain is always all the real numbers. If the domain of the function is all the real numbers, it does not have type 2 critical values. If the domain of the function is all real numbers, if the domain of the function is all real numbers, it does not have any type 2 critical values. Polynomials, domain is all real numbers. Polynomials never have type 2 critical values. So here, what do? You do not skip it. You do not fail to write this. You do not skip this. You say there are none, and then in parentheses you write how you know there are none. The reason you know there are none is because this is a polynomial. If you want full credit out of me, if there are no type 2 critical values because it's a polynomial, you will write type 2, you will write f prime does not exist, and you'll say none because it's a polynomial. If you want full credit out of me, that's what you're going to write. If it's not a polynomial, then you might well need to go look for them. We'll talk about that later on. We will talk about the various scenarios and all the examples we're discussing. But for now, for a polynomial, type 1, set f prime to 0, find the derivative, set it to 0, and solve. Type 1 critical values. Type 2 critical values, that's where the derivative does not exist. For a polynomial, you simply write the word none, and you indicate that you know the reason there are none is because it's a polynomial. If I see this, I interpret this as you know what you're doing. If I do not see all of this, I interpret this as you do not know what you're doing. So we have two critical values. Now we recall, where do the maximum, minimum occur? Where do they occur? They might occur at a critical value, but there's one other possibility. Where might the maximum, minimum occur? They might occur at one of the endpoints. Remember, we've had pictures like this. We had pictures where max and min occurred somewhere inside. We also had pictures where maybe the maximum was at one of the endpoints, or maybe the minimum was. And so we also need to check out the endpoints. And so here's the procedure. Once you find the critical values, we got our type 1s, and if there had been any, we would have gleaned out our type 2 critical values. In this case, there are none. Now, you go back. As soon as you have found the critical values, and here's the piece. As soon as you have found the critical values, you are done using the derivative. The derivative has done its part for king and country. It salutes and goes off to retirement. Once you have found the critical values, you do not any longer, in this procedure, use the derivative. The derivative is only used to find the critical values. If there had been any over here, we would use it to find it over here. Once you find the critical values, thanks for coming out derivative. We're done with you. You may now go off stage. The derivative does not return on stage anywhere else in the play. Not even for the curtain call. It's gone. Once you find the critical values, now we go back and we compute the original function. And you must, in the wonderful line from Casablanca, you must line up the usual suspects. Round up the usual suspects. You must do the critical values, f of 0. We must compute f of -1, because that's the critical value. We must compute f of the endpoint. So these are the critical values. These are the endpoints. Well, notice we have a repeat. If you have a repeat, you don't need to do it twice. If you have a repeat, you don't need to do it twice. Hope you enjoyed that. If you have a repeat, you don't need to do it twice. You don't need to do it twice. But we do have to do 2. All right? And all you do is take this value, substitute it into the original function. So this is 3 times 0 to the 4th minus 4 times 0 to the 3rd. Well, I can do that, and I'm from Missouri. 0. F of negative 1 is 3 times negative 1 to the 4th minus 4 times negative 1 to the 3rd, which is 3 times 1 minus 4 times negative 1. Be careful, negative 1 to the 3rd power. Whenever you do negatives, whenever you substitute, you should always substitute with parentheses. So if you're using your calculator, whatever you do, make sure you do the arithmetic correctly. It's a shame students do the rest of the stuff correctly and then they botch up this arithmetic. So make sure you do the arithmetic correctly. So this is 3 plus 4 is equal to 7. All right. And then we have f of 2, which is 3 times 2 to the 4th minus 4 times 2 to the 3rd, which is, oh goodness, that's 3 times 2 to the 4th is 16, minus 4 times 2 to the 3rd is 8. 3 times 16, I believe, is 48. Check my arithmetic. 4 times 8, I believe, is 32. And I believe that's 16. So see what I did? Find all the critical values. Once you found the critical values, derivative is done. Get rid of it. Find f of 0, f of negative 1, and f of 2. 0 because it's a critical value, 2 because it's an endpoint, and negative 1 was actually both. So it would have done. You would have done it from here. You would have done it from here. Here's a big important what if scenario. What if? What if? What if? What if? When we were finding the critical values, what if we had also found x equals 5? What if we had also found x equals 5? If you use x equals 5, you do not use 5 because 5 is not in the interval of interest. We are only concerned with x values between negative 1 and 2. This is a common mistake. In fact, you know I'm going to do this on the exam. You know I'm going to give you an example where this happens just to see if you know what you're supposed to be doing with it. If the value you get is not in the interval, you do not use it. It does not pass muster. So if you generate values here that are not in the interval, those values are not used in this further computation. If we had gotten negative 3, you would not use negative 3. If there had been critical value type 2, if a critical value type 2 had been x equals 1, you would use it. Critical value type 2 had been x equals 10, you would not use it. The only critical values you use are those that satisfy the original condition of the problem. All of these did. So now, the last piece is this. Which one of these is the maximum? Which one of these is the minimum? Well, it's not very hard to see. That's the big one, that's the little one. There it is. So there's a maximum, and it's an absolute max because it's absolutely on this interval. Anytime you have a closed interval, we're finding an absolute max. Absolute max at x equals 16, and the max value, I'm sorry, I said that incorrectly. The maximum value is x equal. What is the x value? See this, we found 2, 16. We just found 2 comma 16. The maximum value occurs at x equals 2. The maximum value is y equals 16. Right? It occurs at 2. That's an x value. The maximum value is a y coordinate. And then the minimum of these three, the minimum is 0, and it occurs at x equals 0. So this is a double here. I'm going to go ahead and write this up here. The absolute minimum at x equal, and then the minimum value is y equals. So which was it? X equals 0. And what was the y coordinate? 0. Absolute maximum occurs at x equals 2. Maximum value is 16. Absolute minimum occurs at x equals 0. Minimum is x equals 0. Minimum value is y equals 0. So what we're going to do next is just go through example, 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 example. We'll go through about 4 or 5 different examples, all the various scenarios, and so this should become just bread and butter to you. Just should be easy money. Be able to go through this procedure, whether it's trigonometry or whether it's a polynomial or whether it's a fraction function, any function in your experience. This should be pretty straightforward for you.